Hello everyone, Prasad Domala here. Today I'll be discussing about SSL Keystores and Certificates. These SSL Keystores and Certificates can be quite confusing if you don't get the basics right. In this video I'll try to explain some of those basic concepts and will show you a demo on how to create and configure keystores and certificates in Fusion Middleware context. You can always apply these concepts to any web server or application server with minor differences in configuration process. Please do have a look at my blog on this topic for step-by-step instructions and commands I'll be using in this video along with the screenshots. I'll leave the link in the description, or you can click on the information icon on the top right corner of this video. Before starting, let me tell you that you'll be able to answer these questions when you finish watching this video. First one, what is SSL? What are the capabilities of SSL? What are public keys and private keys? What is a keystore and available keystore types? And what are certificates and available certificate types? And finally, how to configure keystores and certificates for Oracle Weblogic server using Keytool and Fusion Middleware Control or EM Console. Let's start with SSL and keystores overview. SSL is an acronym for Secure Sockets Layer, and it is an industry standard for securing communications between client and server. In most cases, the client will be a web browser and the server will be an application server like Weblogic or a web server like Apache and OHS. Let's see what is SSL capable of doing. It mainly performs three functions. Number one, it is capable of encrypting the data that's being transferred between client and server. There are many encryption algorithms supported by SSL like RSA, DES, AES and so on. And RSA is the most commonly used algorithm. Number two, it's responsible to maintain data integrity by making sure that the data is not tampered during the communication process. This data integrity is maintained by generating a digest using hash functions. In this process, client hashes the message and sends the result, which is called as digest, to the server. On the server side, the server also generates the digest using the same hash functions and compares the resulting digest, and obviously the message is untampered if the digest matches. SHA-1 is the commonly used hash function in SSL, and it's practically impossible to generate identical digests for different messages. And finally, it is responsible to mutually authenticate client and server, which prevents unintended data transfers. When the client initiates the SSL session, server sends the digital certificate signed by third-party certification authority to the client, and the client verifies the trust or root certificate in the certificate chain. The third-party CA, that is certification authority, guarantees that the certificate is valid. If the trust certificate is not in the browser's trust store, or if the certificate is expired, then the SSL communication will not happen and the browser complains that the certificate is not valid. And these are the three main capabilities or functionalities of SSL. Now let me briefly explain about public keys and private keys. Private key, as the name suggests, it's a secret key. It is also called as symmetric key. In private key cryptography or symmetric key cryptography, same key is used to encrypt and decrypt the messages. So the client and server should have the same copy of the private key for encryption and decryption purposes. This type of cryptography is faster and obviously is more common when huge data transfers are involved. Public key, on the other hand, is public and is commonly wrapped into the digital certificate, and each public key will have an associated private key. Messages encrypted using a public key can only be decrypted using an associated private key and vice versa. In public key cryptography or asymmetric key cryptography, when the client initiates the SSL session, server sends the certificate to the client along with the public key. Before encrypting and sending the message, the client verifies the server's authenticity using the CA's digital signature on the certificate. Once authenticated, the message is encrypted using the embedded public key and sent to the server, which then will be decrypted on the server using associated private key, which is kept secret and never revealed to anyone except the server or the owner. You can have either one-way or two-way SSL here. In one-way SSL, only the server is authenticated by the client, and in two-way SSL, both client and server authenticates each other, where the client should also have the certificate installed. One-way SSL is more common in internet-based websites or web applications. That's about private keys and public keys. Now let's talk about keystores. There are two keystore providers, JKS, that is Java Keystore, and Oracle Wallet, or KSS, that is Oracle Keystore Service. JKS is used for Oracle Weblogic server and all applications deployed on Weblogic server, including SOA Suite, Oracle Web Center, Oracle Virtual Directory, Oracle Identity and Access Management, and so on. And Oracle Wallet is used for Oracle HTTP server, OID, that is Oracle Internet Directory, and Oracle Web Cache. And coming to the keystore types, we have Identity Store and Trust Store. Identity Store holds private key and digital certificates, or commonly called as server certificates. And Trust Store holds certification authorities trust certificates. These can be root or intermediate certificates in the certificate chain. You can store private key, server certificates, and trust certificates in a single store, but it's advisable to use different key stores for identity and trust in production environments, because these have different security requirements. Identity Store should be more secure as it holds sensitive information like server's private key, but Trust Store can be less secure as it holds publicly available trust or root certificates. So generally it's a good idea not to combine these two stores in production environments. Okay, that's a brief overview of SSL and keystores. Next, I'll show you how to manage keystores in Fusion Middleware context. So this is my VMware where I have my Weblogic server 12c installed and have my domain created along with the EM template. I have my domain started. Let me access the EM console now. It's running on my 7001 port /EM. If you have worked with 11G versions, you will notice that the look and feel is completely changed in 12c. Navigate through different sections on the console to make yourself familiar with the new console. So I'm logging in with my Weblogic ID. This is my EM console's home page. To create a new keystore, you need to go to Weblogic domain and then security and keystore. Here you can see some default demo keystores already created under system stripe. A stripe is nothing but a unique reference which holds your keystores. You can either create a new application stripe for your new keystore or use existing application stripe. I am creating my keystore inside system stripe. So click on create keystore here. Provide a name for your keystore. I'll call mine as my test keystore. And for protection, you have policy based or password based. You can use policy based if you have integrated your Weblogic domain with Oracle Platform Security Services, which is a central security management service. Here I'll use password based. Keep this password safe. You cannot reset it if you lose it. It can only be changed using the old password. And provide your keystore password. And here you have an option to grant permissions to this keystore using a code base URL. For demo purposes, I'm not using it. You can click OK here. So our keystore is now created under the system stripe, as you can see. If you're doing this in production environments, you can create two separate stores for your identity and trust stores and name them accordingly. Next, we need to generate a key pair. A key pair is a public key, private key combination signed using a demo certification authority. So select your newly created key store and click manage here. You need to provide your password. So as you can see, we don't have any key pairs here. So select generate key pair. Here you need to provide details specific to your key pair. So for alias, I'll give it as my test alias. Common name, I'll just call it as my test key. OU, call it as test OU. Test organization, city, test city. Country, United Kingdom. And then you can select the key type here. The default is RSA, so I'm selecting the default one. And next you can specify the key size here. So you have different options for key size. You can go with the default value, that is 2048, and then you need to provide the password of your key store. Click OK. Now your key pair is created, as you can see. So these are the details of your key store. Next you need to generate a CSR, that is a certificate signing request, which you need to send to a third-party certification authority. So you select your key pair and click generate CSR. Provide the password. This is how a CSR looks like. You can copy this content into a text file, or you can save the CSR into a text file here by clicking on export CSR, which you need to send to a third-party certification authority. Once the data is verified by the certification authority, it issues two things: a root or a trust certificate and a server-specific digital certificate. The root certificate should be imported to your trust store, and the server certificate should be imported to your identity store, if you have to separate stores for your trust and identity. So I'm closing this here. Once you receive the certificates from the third-party certification authority, you can import them by clicking the import button here. And here it will ask you what type of certificate you are trying to import. So you can either import a trusted certificate or a server's digital certificate. And then you need to provide the alias. It will list down the available alias. So you need to select the same alias which you use to generate your CSR. Otherwise your certificate will not be imported. And then you need to provide your password for your alias. For certificate source, you have two options. You can either paste certificate directly into this text box here, or select the second option and specify the location of your received trust or digital certificates. Here I'm not importing anything as I don't have any third-party certificates, but this is how you import your certificates when you receive them from your third-party certification authority. So that's how you manage your key stores and certificates using middleware control or EM console. Now let's see how you can perform the same steps using Java Keytool. So before executing the Keytool, make sure your Java environment is set properly. Make sure the Java executable is added in the path. So mine is already added. You can check the path of the Keytool utility as well. So Keytool is an utility that comes along with your JDK, which can be used to create and manage JKS based key stores. So the first step is to create a key store and generate key pair. When we used EM console previously, this was done in two steps, but Keytool does it in a single step. So the command is Keytool -gen key pair, and then you need to provide your alias. So I'm giving mine as my test alias, and then you need to provide the key algorithm, that is -key alg, I'm providing it as RSA. Then you need to provide the key size. That would be -key size. I'm giving it as 2048. And then you need to provide a name for your key pair. This name should follow the X509 standard or LDAP standards. So I'll give mine as say cn is equal to mycompany.com, comma say country is equal to GB. And then you need to provide a keystore file. So -keystore and then my file name. I'll just call it as my test keystore.jks. JKS is the file extension for your Java Keystore based keystores. Execute that. It will ask you to provide a password for your keystore. Confirm the password. And then it will ask you whether you want to use the same password for your keystore and the keys. So I'll use the same password. So just hit enter. And that's it. Your keystore should be created. So this is the keystore file. So if you want to view this keystore, you can always execute keytool command again and then -list option. And if you want verbose mode, you can give -v and then your keystore name, that is -keystore, and then your file name, that is mytestkeystore.jks. Then it will ask you for the password and it will list down all the entries in your keystore. As you can see, the keystore type is JKS and our keystore has one entry, that is the new key pair which we just created. It's nothing but my test alias, and then all the values for your key pair. Okay, the next step is to create a certificate signing request, that is CSR. So you can do that using Keytool. This time -cert rec option, and then if you want verbose, you can give -v, and then you need to provide the alias. And then you need to provide a file name where you want to store your CSR. So I'll just give -file and say my csr.csr. Then you need to provide the keystore, -keystore, again my test keystore.jks. So this will generate the CSR and stores it inside your file name, mycsr.csr. It will ask you for the password. Okay, now if you open your newly generated CSR, you can see the content. So this is how your CSR looks like. You can send this to your third-party certification authority. And once you receive the trust certificates and digital certificates from your certification authority, you can import them using these commands. Keytool, this time -import cert, and then your file name -file. So this is the certificate file name which you received from the third-party CA. Say for example mycert.cer or PEM, whatever files you received from your certification authority. And then you need to provide your alias, say my test alias. You need to provide the same alias which you used while generating your CSR. And then you need to provide your keystore name, -keystore, and then my test keystore.jks. So this command will import your certificates into your keystore. So that's how you can create keystores and import certificates using Keytool. Here I'm not importing any certificates, so I'm cancelling this command. Once the key store is ready and the certificates are imported into the key store, it's time to configure Weblogic server to use the new key stores. Let me log into my Weblogic console. It will be running on 7001/console. Log in with your Weblogic ID. So this is Weblogic console's home page. So to configure the key stores, you need to navigate to environment, servers, and then your admin server or managed server, where you want to configure your new key stores. Here I'm selecting admin server, and then under configuration you have a tab called as key stores. As you can see, by default Weblogic uses demo identity and demo trust stores, which gets created during the installation. So now we'll change them to use our custom key stores. Before that, you need to, if you're running in a production mode, you need to lock and edit and then click change here. Here you have 4 options for key stores. The default one is demo identity and demo trust. Next you have custom identity and command line trust. You can select this if you want to use the key store you created as an identity store and pass the trust store as a command line argument while starting your Weblogic server. And next you have custom identity and custom trust. Select this if you want to use custom key stores for both identity and trust. Then you have custom identity and Java standard trust. You can select this if you want to use custom store for identity and JDK's inbuilt store as your trust store. So if you are not aware, JDK comes with the default trust store that contains almost 90 plus trust certificates. Let me quickly show you the trust store, the JDK's default trust store. So it will be under your JRE lib security directory. So let me navigate to my JRE. That's /JRE lib and then security. So here you can see a file called as CA-certs. So this is your default trust store that comes along with your JDK. If you want to view the contents of this trust store, you can always use keytool command, keytool -list. Then if you want verbose -v and then -keystore and then your file name, that is CA-certs. And it will ask you for the password. The default password for JDK's trust store is change it, that is CHANGEIT. Once you enter, you can see the list of all the trust certificates. You can see the trust certificates from most of the third-party certification authorities. Let me grep on alias name so that you can see the names of the certificates. So I'll just pass the password in the command itself. That will be store pass, that is change it, and then let me grep on alias name. It will give you the list of names of your trust certificates. As you can see, these are all the trust certificates that comes by default with your JDK. So you can see DigiCerts, Komodo, and many other companies, Entrust. GoDaddy, VeriSign. So this is the default JDK's trust store. So let me come back to the console. So you can select this third option if you want to use custom identity and Java's default trust store. So here in this case, I'll select the second option, custom identity and custom trust, and then click save. Now you need to provide the details of your key store. So you have 2 sections here, identity section and trust section. So the first one is identity key store. So if you are using the key store created using the EM console, that will be of type KSS, that is nothing but Oracle key store service. So this will be the syntax. So you need to provide KSS as protocol and then : / and then you need to provide your application's type name. In our case it is system, and then you need to provide your key store name, my test key store, and then the type would be KSS, and you need to provide the password for your key store. So if you are using JKS based key store, here you need to provide the absolute path of your JKS file. So in our case, like say home Oracle and then my test key store dot JKS, and then the type would be JKS. If you have created a different key store to store your trust certificates, you can provide those details here. If you are using a single key store for both identity and trust, you can provide the same details in both these sections, and then save. Once the key store changes are done, you have two options to activate them actually. So if you go to servers and then control tab, you have something called as restart SSL. Restart SSL activates SSL for all new connections. If you want to enable SSL for all the connections, it's always better to restart your managed server or admin server. And that's it. You now know the basic concepts of SSL and how you can configure key stores and certificates for Oracle Weblogic server. If you have any questions, please post them in the comment section, and please have a look at my blog on this topic for step-by-step instructions and screenshots. I'll leave the link in the description. Hope you liked the video and found it helpful. Please give me a thumbs up if you did, and do subscribe to my YouTube channel for more technical videos like this one. Bye for now, and see you in the next one.